Hey Adam, hope you're doing okay. With the new school year coming along, I know it's going to be a busy time, but thank you so much for sending me your test results. I got that and had a chance to review them. Thank you so much for doing all the problems that I asked you to do. And like I said, I'm going to do everything I can to help you out and make sure that you get your goal score in the end. So let's try to get you prepared so that you can take this test, this current version of the test, get it over with, and so that you don't have to deal with preparing for a brand new test come March 2016. I'm going to be taking you through three different sections, Section 2, Section 4, and Section 8. The diagnostic test that you took is actually College Board test number 5. So if you have the book that we sent over to you, it's test 5 in that book. So you can follow along there if you want to. But I'm going to be going through all the questions that you answered incorrectly in the problems that you sent me recently. All the questions that you answered incorrectly, and also the ones that you omitted. So let's jump right into Section 2. We're going to go to number 4. So in this video, I'm going to send you a series of 3 videos, links to 3 videos. In the first video, we'll do Section 2, then we'll do Section 4, and the third one, Section 8. So in this first video, we'll do Section 2, numbers 4, 15, 17, 19, and 20. Okay, so we'll go through those 5 questions. Let's jump right to number 4. In test 5, section 2, number 4, here's the question. For which of the following functions is f of -3 greater than f of 3? Now, on the SAT, whenever you see f of x or h of t or any function like this, always this is your y coordinate, okay? Just like, you can write y equals x plus 1. That's a function, for instance. You can rewrite the y as f of x equals x plus 1, and this is just in function notation. These two mean exactly the same thing. And so the y and the f of x, now remember this is not a multiplication here, this is the f of x. So this is the function, and f is just the name of that function. But in any case, this whole thing is the same exact thing as the y. So keep that in mind throughout this entire test. So here they're saying some y value is greater than some other y value. Right? So what are the y values we're comparing here, right? In the first case, we have an input, the x, right? It's f of x. So the x is -3 in the first case. And in this case, x is a 3, a positive 3. So for which of the following functions is this true? So let's look at a, for instance. A gives you this function, and each one gives you a different function. Let's test this one. F of x is equal to 4x squared, which means, so to find this guy, let's find this guy first. Okay, what does f of -3 equal? F of -3 just means stick in a -3 in for x instead, right? A -3 right there, right? That's what this is. So in place of this x right here, I'm also going to put in a -3. So what I have is 4 times -3 squared. -3 times -3 is a positive 9. So this gives you 4 times 9, which is a 36, right? So this value right here would be a 36. Is that greater than f of 3? So let's try this one. So this time, they want us to put in just the 3, right? So f of 3, what is that equal to? That is equal to 4 times 3 squared. 3 squared is 9. And that's again equal to 36, right? And so is 36 bigger than 36? It is not. They're equal. And so A is not the answer. And you would go down through each of the answer choices. So I definitely want you to try this out on your own as well. Maybe you can pause me now and try the rest of these. But the answer to this one is actually going to be, try it first before you listen to the answer. Always, you want to put in your own practice at all times. Okay? Don't just watch me do the problem and say, oh, that's how you do it, and leave that be. That doesn't become yours, right? You can't become a master at solving these problems by observing me do a bunch of problems, right? You have to do them yourself. And every time you do a problem, you're adding to that mastery. So I'm going to tell you that the answer is D. So hopefully you have had a chance to go through all the other ones. But if you try D, here's what happens. F of, let's put in a -3 first. F of -3 would equal 4 minus a -3 cubed, right? So that equals 4 minus a -3 times -3 is positive 9, times another -3 is a -27. right? So this is going to be negative, and minus a negative number is going to be a positive. So 4 plus 27 would be a 31. This value here is then a 31. Is that greater than, let's try this side, f of 3 now. So let's find f of 3. Put in a 3. If you put in a 3 for x, you get a 3 right there, right? So 4 minus 3 times 3 is 9. 9 times another 3 is 27. So this time I have 4 minus a 27, which is a negative value, right? You don't even have to figure out exactly what it is. I just know that this number is negative, and is this positive number, sorry about that mess, is this positive number bigger than this negative number? Sure it is, right? Positive numbers are always bigger. And so D will be the correct answer because it gives you a true statement for this one. For which of the following functions is this one true, is the question here. So D is the correct answer to number 4. Let's look at number 15. Is the next one we need to discuss. And here it is. Okay, we have two triangles, figures not drawn to scale. We know that these base angles are the same, which means that tells us that this is an isosceles triangle. These two sides must be the same. Okay, these two are the base angles, so the side opposite that and the side opposite that should be the same angle, same sides, so same lengths. So if that's an 8, that has to be an 8. Okay, so same thing here, right? That's a y, and so the opposite side here and the opposite side here, these two sides must also be the same. Okay. I know I have the same base here, but I don't know what the angles are, so I can't really say that everything is 8 yet. So don't jump to conclusions there yet, but never make assumptions on this test. Always figure things out when you're answering these questions. In number 15, if y equals 60, so this here is 60, which means this is 60, right? So what is this? What does that make this triangle? If that's a 60, that's a 60. We know that there are 180 degrees in the entire triangle. And so this must be another 60, right? For a total of 180. It turns out to be an equilateral triangle, which means if this is a 5, this must be a 5. And this must be a 5. Okay? We're just notating as they give us the information. Okay? So try to organize all the information as they're given to you. So in DEF, that's the case. How much greater is the perimeter of ABC than the perimeter of DEF? They want us to compare the two perimeters. And with that, I think you can figure the rest out. The perimeter of this side, or this triangle, would be 8 plus 8, which is 16, plus 5 is 21. The perimeter of this triangle is 5 plus 5 is 10, plus another 5 is 15, right? So how much greater is the perimeter of this one than this one? The difference between 21 and 15 is, of course, 6. So C would be the correct answer to number 15. Going to number 17. In the xy plane, line L passes through the origin and is perpendicular to this line where k is some constant. So they don't give us what that number is, but it stands for some constant, some number. If the two lines intersect at the point t, t plus 1, right? So that's your x, and t plus 1 is your y. What is the value of t? So in this xy plane, all right, here's my x-axis, my y-axis. Line L passes through the origin, so here's my origin, passes through there, 0, 0. And it's also perpendicular to this line, right, where k is some constant. And I don't know what that is. Now, where k is if the two lines intersect at the point t, t plus 1. What do you know about that point t, t plus 1? If two lines intersect at a certain point, in this case t, t plus 1, where is that point? It's actually on both lines, isn't it? Right? If two lines here are two lines right here, and they intersect at this point, does this point exist on this line? Sure it does. Does this point exist on this line? Sure it does, right? So we know that t, t plus 1 exists on both lines. What is the value of t? Now, here's something you could do. Because I know that this point lies in this equation and also in The other equation that they try to describe to us, but they don't give to us, we know that we can just kind of stick it in, and hopefully we can figure this out. Like, what I mean is, this is your x, and this, remember, is your y, right? Your x comma y. So t can go in for x, and t plus 1 can go in for y. But then I still have the k, and I don't know what the k is, and so that actually doesn't give me the answer, right, unfortunately. But here's something else we know. Perpendicular. What does that mean? If two lines are, first of all, parallel, what do you know about their slopes? Their slopes are equal, right? They have the same slope. But if two lines are perpendicular, if you have a line here, and if you have a line that is perpendicular, what do you know about the two slopes? Well, if this slope has a slope of, let's say, a half, right? What do you know about the perpendicular line? It's the opposite reciprocal. So this is positive, so the opposite is negative, and the reciprocal is just flipping the top and bottom, which is 2 over 1, right? So the slope of this line would have a slope of negative 2. How does that apply here? We're given one equation of a line, right? 4x plus y equals k. But here's my favorite form of all line questions. The slope-intercept form. Do you remember that? Y equals mx plus b. If you change it into this form, you can find that slope, can't you? So I'm going to solve this one, isolate the y. Solve this one for the y. So if I rearrange this thing by subtracting 4x on both sides, I'll get y equals the negative 4x plus a k. So what do I just find? I just found the slope of this line, right? Line L passes through the origin and is also perpendicular to this line. This line has a slope of negative 4. That's not my line, that's not line L, but that line has a slope of negative 4. What do you know about our line, right? Line L. We know now that the slope of line L, our line, is the opposite reciprocal. This is negative, so the opposite would be a positive. And the reciprocal, this is just a 4 over 1, right? So if you flip that, you would get a 1/4. So your slope is a positive 1 over 4. It also goes to the origin, so maybe this already makes sense to you. Y equals, the slope is 1 over 4. You have your x, and then what would be your b, the y-intercept, which is that point right there. That's all your slope and your y-intercept, which is why it's called the slope-intercept form. And my y-intercept, if it goes through the origin, it's just a 0. And so I have my equation. Y equals 1/4 x. All right? So I know that this point, t comma t plus 1, once again, goes through both lines, this line and this line. Which line should I put it into? I should put it into this line because this one has that unknown, right? So if you use this equation to plug in a t for x and t plus 1 for y, you get y is, I'll write it over here, y is t plus 1, and that equals the 1/4 times the x is a t. Right? What is the value of t? All you need to do now is to solve this equation here. T plus 1 equals t over 4 is something you can do, or you can, I guess, just multiply both sides by 4 if you want to, right? So if you multiply both sides by 4, I get a 4t plus, remember a 4 you have to distribute, equals 1/4 times 4 is just a 1, and you have your t. Subtract t on both sides, you get 3t. Send the 4 over, you get negative 4. And divide by 3 on both sides, t equals negative 4/3 will be the correct answer. So A will be the correct answer for number 17. Number 19 is your next one. Here is your figure. Hopefully you have it in front of you as well, but here's the question. In the figure above, actually let's look at this here first. In the figure above, triangle XYZ, here's XYZ, is equilateral. Equilateral. So all three sides are the same, and each angle must be 60 degrees. With side length of 2. Okay, so if this right here is a 2, so is this one, and so is this one, right? We also know, again, that this is a 60, this is a 60, and this is a 60. Now, whenever you're given equilateral triangles, almost always on this current version of the SAT, I want you to mentally link all equilateral triangles to 30, 60, 90 triangles. Whenever they give you an equilateral triangle, think 30, 60, 90. And hopefully you know your 30, 60, 90 and 45, 45, 90 special triangles. If you don't, there's a lesson on that, so make sure you refer back to that. But that's almost always the key to the problem, okay? And so already you can see, I didn't read the question yet, but you can already see that I have an equilateral triangle. Hey, what does it look like? I have a 90 degree here. Here's another right triangle. And if that's a 90 and that's a 60, that right there must be a 30, right? And so it's likely they're going to use the 30, 60, 90 triangle for this problem. Let's see what they do, or what they ask for. If WY, here's WY, is a diameter of the circle, so it goes to the center, and it's the diameter of the circle, with center O, okay. Then the area of the circle is, how do you find the area of a circle? It's always pi times the radius times the radius, so pi r squared, right? So the whole thing, the most important thing here is to find r, the radius. So what is that radius? It's from here to here, or from here to here, right? Basically half of that side right there, okay? If WY is the diameter of the circle, oh, then the area of the circle is, so we have to find the area. Let's first find the radius of the circle then. What can we do? Well, we know that we have a 30, 60, 90 triangle, and in a 30, 60, 90 triangle, the relationship among the sides are, if this is x, this is 2x, so that's double, and this is x root 3, x times root 3, right? So hopefully you know that relationship. And so if this right here is supposed to be double this, that should be a 1, right? This portion right here. That's a 1, that's a 2, and this right here is a 1 times root 3. So 1 root 3 is just a root 3. That's the entire diameter. So what would be the radius? It's half of that. It's the root 3 over 2, right? So with that, can we find the area? Sure we can. The area equals pi times the radius, which is root 3 over 2, squared. Pi times, now the squared is for everyone inside the parentheses, so root 3 squared is root 3 times root 3, which is just a 3, over 2 squared is a 4. So 3/4 pi looks like is the answer. Let's look for that. Do we have that? 3/4 pi? We have it right here, right? 3/4 pi, that's another way to write it. If you have 3/4 times pi, that's really 3/4 times pi over 1, right? So if you just multiply straight through, you get 3 pi over 4. So C would be the correct answer for number 19. And the last one in section 2 is number 20. Let's take a look at this one. When 15 is divided by the positive integer k, the remainder is 3. For how many different values of k is this true? So we have to take 15 and we divide it by some number k. K is a positive number. And we divide it by k. The remainder has to be 3, right? What number works that way? Well, something comes to mind. 12. Hopefully you were able to think of 12, because if you take 15 and you divide it by 12, right, it's 3 short of 15, isn't it? So that means 12 taken into 15. 12 goes into 15 how many times? Just 1 time, right? 12 times 1 is 12. 12 goes into 3 0 times, doesn't go in anymore, I'm done. So my remainder here is 3, right? If you remember back to elementary math, that's how you would get a remainder of 3, right? So for how many different values of k? So if k were 12, this would be true. I know that there's at least one answer, but I knew that from the answer choices already, because the smallest number I can come up with is 1, right? I know there's at least 1, but are there other numbers that also give me a remainder of 3? So the magic number here is how do I get to 12, right? How do I, what factors make up 12? Think of that first. Now, that's not necessarily the complete answer, because some of them will not work, as you'll see in just a moment, right? What factors make up 12? Well, 1, 2, 3, 4, 6, and 12, right? 3 times 4 is 12, 2 times 6 is 12, 1 times 12 is 12. I was able to match everything up, so I know I didn't miss anything here, right? So at most, there would be 6, but some of these won't work. Why? First of all, will the 1 work? Sure, 1 goes into 12, but it also goes into 15, doesn't it? Right? So 15 divided by 1 wouldn't give you any remainders at all. So this one is out. The 2 goes into 12. Sure, I can get 2 to be a 12 by multiplying by 6. But if you try 15 divided by 2, the 2 also goes into 14, right? So it goes in extra time. You won't have a remainder of 3, will you? And so you can't really have numbers any smaller than 3, because if the number being divided is, or the divisor is smaller than the remainder, of course it goes in an extra time. I don't know if that makes sense to you, but you can try that. 2 also doesn't work because it goes into 15 7 times with a remainder of just 1, right? 3. Does a 3 work? 3, sure, you can get to 12, but 3 also goes into 15 evenly, doesn't it? With a remainder of 0. Well, that doesn't work. So at most we have 3. We know that 4 and 5 are not the answers so far. How about 4? 15 divided by 4? Does that work? Yes, it does. Right? So 4 goes into 15. How many times? 3 times, which is a 12, with a remainder of 3. It doesn't go in anymore. Right? So 4 would work. How about a 6? 6 also works. Right? And how about a 12? 12 also works. These 3 numbers give you a remainder of 3. So C would be the correct answer for number 20.